হ্যালো স্টুডেন্টস, ওয়েলকাম টু আওয়ার চ্যানেল। আমরা এই ভিডিওতে আজ ক্যালকাটা ইউনিভার্সিটির সেমিস্টার 2 CC2 পেপারের 2022 কমপ্লেক্স নাম্বারের কমপ্লিট সলিউশন করতে চলেছি। তোমরা জানো নিউ এডুকেশন পলিসি অনুযায়ী মেজর অ্যান্ড মাইনরের সেমিস্টার 1 অ্যান্ড সেমিস্টার 2 সেম সিলেবাস। সো এই ভিডিওটা তোমাদের সবার জন্যে খুবই ইম্পর্টেন্ট। 2022-এ কমপ্লেক্স নাম্বার থেকে টোটাল আমাদের 4 কোয়েশ্চেন্স এসেছে, যার মধ্যে দুটো ছিল MCQ ইচ অফ 2 মার্কস অ্যান্ড দুটো 5 মার্কসের কোয়েশ্চেন। সো দ্যাট মিনস 2 + 2 + 5 + 5 টোটাল 14 মার্কসের কোয়েশ্চেন 2022-এ ক্যালকাটা ইউনিভার্সিটিতে এসেছিল। তোমাদের NEP-তে MCQ আর নেই, এখন 2.5-এর কোয়েশ্চেন আছে। তো এই MCQ-গুলো কিন্তু এখন 2.5-এর কোয়েশ্চেন হিসেবে এক্সামে আসতে পারে। সো MCQ-গুলো কিন্তু প্র্যাকটিস করাটা খুব ইম্পর্টেন্ট। তো চলো ফার্স্ট কোয়েশ্চেন কি বলছে দেখা যাক। দ্য প্রিন্সিপাল ভ্যালু অফ -1⁻I ইজ সলিউশন। আমরা জানি a to the power z is equals to exp z logarithm of a, where a is non-zero complex number and z is any complex number. So a to the power z is equals to exp exponential z log a. This log is general value of the complex number a, where a is non-zero complex number and z is any complex number. Here to find the principal value of -1⁻I. So here -1 is complex number and I is also complex number. So what is the principal value? Principal value of a to the power z is equals to exp exponential of z log a. এই log মানে হচ্ছে principal logarithm and this is general logarithm. So principal value of a to the power z is exp z log a, where this log is principal logarithm. Log a is equals to principal logarithm a plus 2n pi I, where n is any integer. So this is the general logarithm. General logarithm is equals to principal logarithm of a plus 2n pi I, where n belongs to z. N is any integer. For n equals to 0, the general value of logarithm of a log a is same as principal logarithm of a. So for n equals to 0, log a equals to general logarithm of a is equals to principal logarithm of a. So principal value of a to the power z is equals to exp z log a. So here a equals to -1 and z equals to I. So therefore principal value of -1 whole to the power I is equals to exp, that is exponential I z, here I, so I log -1. We know that logarithm of negative is undefined in real number system, but here we taking -1 as a complex number. So in complex number system logarithm of -1 is defined, but in real number system logarithm of -1 is not defined. So logarithm of a is equals to logarithm of modulus a plus I into argument a. Since a is any complex number, so logarithm of a is logarithm of modulus of a plus I into argument a. So this is the formula for finding principal value of logarithm a. So here -1, a equals to -1. So this implies modulus of a is equals to 1. we may write minus 1 as 1 into cos pi plus I sin pi, because sin pi is 0 and cos pi is minus 1. So a equals to minus 1 means 1 into cos pi plus I sin pi. So this is of the form r into cos theta plus I sin theta, where r is modulus of the complex number and theta is amplitude or argument of the complex number. So modulus of a is 1 and argument of a is equals to pi. So therefore logarithm of minus 1 is equals to logarithm of modulus of minus 1 is 1, modulus of mod a is 1 plus I into pi, I into argument a means I into pi. So log 1 is 0, so logarithm minus 1 is I pi. So this is equals to exp. I times logarithm of minus 1 is our I pi. So into I pi. So this is equals to exp I square minus 1. So minus pi. Since this is real number, so this is e to the power minus pi. So principal value of minus 1 to the power I is e to the power minus pi. So option 2 is correct. So we move to the next question. Now the next question is one part each. The point z equals to x plus iy on the organ plane, that is complex plane, satisfying e to the power iz equals to minus 1 lie option 1 in an ellipse, option 2 in a straight line, option 3 in a circle, option 4 in a parabola. Solution. E to the power iz equals to minus 1. E to the power iz equals to minus 1. So this implies iz is equals to logarithm of minus 1. So this is the general logarithm. We are taking here general logarithm. So logarithm of minus 1. So we know that logarithm of z is equals to principal value of logarithm z plus 2n pi I, where n is any integer. Okay. So logarithm of minus 1 is equals to log of minus 1, that is principal value of minus 1 plus 2n pi I. Now we want to find logarithm of minus 1. So in previous sum we calculate logarithm of minus 1, which is our I pi. So this is equals to I pi plus 2n pi I, where n belongs to z, n is n integer. Okay. Log of minus 1 is I pi. So this implies z equals to 2n plus 1 into pi, where n is any integer. So here z is x plus iy. So this means, this implies x plus iy is equals to 2n plus 1 into pi plus I into 0. Then this implies x equals to 2n plus 1 pi and y equals to 0. So that means the points z, x plus iy lie on the line y equals to 0. So therefore the points z equals to x plus iy lies on the real axis, because y equals to 0 is the equation of real axis. So therefore the point z equals to x plus iy lies on the real axis, that is lie on a straight line. So the option 2 is correct here. Next question আমাদের একটা 5 marks a question, two part A. Find the roots of the equation z to the power n equals to z plus 1 whole to the power n, where n is a positive integer greater than 1, so that the points which represent them in the z plane are collinear. তার মানে এই যে রুটস অফ দ্য ইকুয়েশন, এই ইকুয়েশনের যে রুটসগুলো তারা জেড প্লেন মানে কমপ্লেক্স প্লেনে একটা লাইনের উপরে লাই করবে, সেটা প্রুফ করতে হবে। সলিউশন। z to the power n is equals to z plus 1 whole to the power n. So clearly we see that here the degree of the left hand side is n and the right hand side is also n. So finally, if we expand the right hand side in binomial expansion, then we get this is a polynomial in complex of degree n minus 1. So this has exactly n minus 1 roots. So this implies z plus 1 by z whole to the power n is equals to 1. First we write the number 1 as modulus amplitude form. So this is 1 into cos 0 plus I sin 0. So this is the modulus amplitude form of 1. Next we write this cos 0 plus I sin 0 as cos 2k pi plus 0 plus I sin 2k pi plus 0, where k is any integer, where k belongs to z, k is any integer. As we know that cos of 2k pi plus theta is equals to cos theta, where k is any integer, and sin of 2k pi plus theta is equals to sin theta, where k is also any integer. So cos 2k pi plus 0 is cos 0 and sin 2k pi plus 0 is sin 0. So this implies 1 plus 1 upon z whole to the power n is equals to cos 2k pi plus I sin 2k pi, where k is any integer. So up to this step k is any integer. Okay. So this implies the n roots of this are 1 plus 1 by z is equals to cos 2k pi plus I sin 2k pi whole to the power 1 upon n. So by De Moivre's theorem, cos 2k pi by n plus I sin 2k pi by n, where in this step where k is 0, 1, 2 up to n minus 1. এই স্টেপ অবধি কে কিন্তু এনি ইন্টিজার, বাট এই স্টেপ যখনই আমরা বাই এন করছি তখন কিন্তু কেটা 0 থেকে n minus 1, বিকজ দ্য n distinct roots of the equation is this. For k equals to 0 we get one root, for k equals to 1 we get another root, for k equals to n minus 1 we get another root. So here k varies from 0 to n minus 1. So the n values of k we get n distinct values of this 1 plus 1 by z. So this implies z equals to 1 upon cos 2k pi by n plus I sin 2k pi by n minus 1. So this is our z. Z equals to 1 upon cos 2k pi by n plus I sin 2k pi by n minus 1. Remember here in this step where k equals to, k runs from 1, 2, 3 up to n minus 1. Because for k equals to 0 we see that cos 0 plus I sin 0. So cos 0 is 1, sin 0 is 0. So 1 minus 1 this is 0 and 1 by 0 is not defined. So in that sense here k running from 1 to n minus 1, k equals to 0 is not valid in this step. Okay. So what are the values of z? Now we substitute, put k pi by n is equals to theta se. K pi by n equals to theta se. So this is equals to 1 upon cos 2 theta plus I sin 2 theta minus 1. This is equals to 1 upon cos 2 theta minus 1. That means minus 2 sin square theta plus 2I sin theta cos theta, because sin 2 theta is 2 sin theta cos theta, and 1 minus cos 2 theta is 2 sin square theta. So cos 2 theta minus 1 is minus 2 sin square theta. So this is equals to 1 upon, we take common here 2 I sin theta common. So this is 2i sin theta যদি আমরা কমন নিয়ে নিই cos theta, এখানে পড়ে থাকবে প্লাস I sin theta, 2i sin theta cos theta plus I square minus 1, so minus 2 sin square theta. এখন now we multiply cos theta minus I sin theta, numerator and denominator both. So this is cos theta minus I sin theta whole divided by 2I sin theta into cos theta minus I sin theta. So this is nothing but cos square theta plus sin square theta. Okay. We multiply the conjugate of cos theta plus I sin theta, so which is cos theta minus I sin theta. So in denominator 2I sin theta, cos theta plus I sin theta into cos theta minus I sin theta is cos square theta plus sin square theta. So this is 1. Now we divide this I sin theta divided by 2I sin theta is minus half plus cot theta divided by 2I. 1 by I means minus I. So minus half minus I by 2 cot theta, where theta is k pi by n. So this is equals to minus half minus I by 2 cot k pi by n. Here k equals to 1, 2, 3 up to n minus 1. So we see that the values of z are minus half minus I by 2 cot k pi by n, where k equals to 1 to up to n minus 1. For k equals to 1, we get one value of z. For k equals to 2, another value. So for distinct n minus 1 values of k, we get distinct n minus 1 values of z. So therefore, we see that here the points are minus half comma minus cot k pi by n by 2. So these points lie on the line x equals to minus half, which is parallel to imaginary axis. Therefore, the points represented by n minus 1 roots lie on the line x equals to minus half, which is parallel to the imaginary axis. So the points represented by n minus 1 roots lie on the line x equals to minus half, which is parallel to the imaginary axis. Okay. Next, move to the next question. Now the next question is 2 part C. If sin of theta plus I phi is equals to tan beta plus I sec beta, prove that cos 2 theta into cos hyperbolic 2 phi is equals to 3. This is the 5 marks question. Solution. Given that sin of theta plus I phi is equals to tan beta plus I sec beta. So this implies sin A plus B. Sin A, sin theta, sin A, cos B, cos I phi. So cos I phi means cos hyperbolic phi. Okay. Cos I phi is equals to cos hyperbolic phi, and sin of I phi is equals to I sin of hyperbolic phi. we know the standard formula. So sin A, sin theta, sin A, cos B, cos I phi means cos hyperbolic phi, plus cos A sin B, sin I phi means I sin hyperbolic phi. So I sin hyperbolic phi. So this is equals to tan beta plus I sec beta. Okay. So left hand side is a complex number, a plus ib form. Right hand side is also a complex number, a plus ib form. So if we compare both sides, so comparing we get tan beta is equals to, comparing both sides, real and imaginary parts, we get sin theta, tan beta is equals to, tan beta is equal sin theta cos hyperbolic phi and sec beta is equals to cos theta sin hyperbolic phi. Now observe that the proof is a relation between theta and phi. So this is independent of beta. So we want to eliminate beta from these two. So we know that sec square beta minus tan square beta is equals to 1. So now we putting the value of sec beta and tan beta here. So this is beta eliminate. So sec square beta is cos square theta sin hyperbolic square phi minus tan square beta means sin square theta cos hyperbolic square phi. So this is equals to 1. Now we see that in the proof involves cos 2 theta. So we multiply both sides by 2. So multiply both sides by 2. So this implies 2 cos square theta means 1 plus cos 2 theta into sin hyperbolic square phi minus 2 sin square theta means 1 minus cos 2 theta into cos hyperbolic square phi is equals to 2. Okay. So this implies we take cos theta common. So cos 2 theta common here. So cos 2 theta into sin hyperbolic square phi minus plus cos hyperbolic square phi. Okay. The remaining term plus sin hyperbolic square phi minus cos hyperbolic square phi is equals to 2. Now we know that cos hyperbolic square phi minus sin hyperbolic square phi is equals to 1. Okay. So this implies cos 2 theta into, what is sin hyperbolic square phi? Sin hyperbolic square phi is cos hyperbolic square phi minus 1. So sin hyperbolic square phi is cos hyperbolic square phi minus 1. Okay. So 2 cos hyperbolic square phi minus 1. We put the value of sin hyperbolic square phi here. So 2 cos hyperbolic square phi minus 1, taking minus common. So if we take minus common, then cos hyperbolic square phi minus sin hyperbolic square phi, which is 1. So this is 1 is equals to 2. So this implies cos 2 theta into 2 cos hyperbolic square phi minus 1 is nothing but cos hyperbolic 2 phi is equals to 2 plus 1 is 3. Okay. So the proof is cos 2 theta into cos hyperbolic 2 phi is equals to 3. So cos 2 theta into cos hyperbolic 2 phi is equals cos hyperbolic 2 phi is equals to 3. So proved. তো তোমাদের যদি কারোর আরও কোনো কোয়ারি থাকে তোমরা এখানে কমেন্ট করতে পারো, যদি কোনো ডাউট থাকে তাহলে কমেন্ট করে জানিও। ওকে, থ্যাংকস ফর ওয়াচিং।